Children, welcome to part 2 of grade 10, chapter 11, constructions. In part 1, we did how to divide a line segment in a given ratio, how to draw a triangle similar to a given triangle according to the scale factor. What are we going to do in this chapter? Now in this part, we are going to draw tangents to a circle. Children, what is a tangent? We have already done this in previous chapter. A tangent is a line which touches the circle at only one point. Now what will happen if we have a circle and a point? Can we draw tangent through this point to the circle? There can be three cases. If the point P is inside the circle, no tangent can be drawn to the circle from P. Because we may try, but whenever we try to draw a line from P, it cuts the circle at 2 points. That is, it becomes a secant. If point P is on the circle, there can be one and only one tangent at this point, and this tangent is perpendicular to the radius at the point of contact. So if we have to draw a tangent at a given point, how will we do this? Join center with this point. Let us draw a line perpendicular to OP at point P. So this line, say L, is tangent to the circle at point P. Now if P is outside the circle, there can be two tangents to the circle passing through point P. Let us try to construct such two tangents to a circle. Let us do this question. Draw a circle of radius 6 cm from a point 10 cm away from its center. Construct a pair of tangents to the circle and measure their lengths. So children, open your compass to a radius of 6 cm and draw a circle. Name the center, say point O. With the help of a scale, take a point 10 cm away from O, say point M. Now we will draw perpendicular bisector of OM. For this, keep the tip of your compass at point O and take the radius equal to more than half of OM and slightly less than OM. Draw two arcs, one above OM and another below OM. Now keeping the radius same, keep the tip of the compass at point M and draw two arcs. Cutting previous two arcs at 2 points, let the 2 points be point A and B. Join A and B to get point P on the line OM, where perpendicular bisector intersects OM. With P as center and radius equal to OP, draw a circle cutting the first circle at 2 points. Name them as point R and point S. Join MR and MS. These are the two tangents to circle from a point 10 cm away from the center. So children, in this way we can draw two tangents to a circle from a point outside it. Now let us measure the lengths of the tangents. They are 8 cm each. Now let us see how this construction works. If we join OR, then angle ORM is equal to 90 degree because angle in a semicircle is 90 degree, or OR is perpendicular to RM. Since OR is radius of the circle and MR is perpendicular to OR, so MR must be tangent of the circle. Similarly, MS is also a tangent. Children, I have a question for you. Construct a tangent to a circle of radius 4 cm from a point on the concentric circle of radius 6 cm and measure its length. Children, let us draw a rough sketch. We have two concentric circles, that is circles with same center and two different radii. So we will take any point on the outer circle and from this point we will draw two tangents to the inner circle. Now children, isn't this just like previous question? Children, do this yourself. Now let us do another question. Draw a pair of tangents to a circle of radius 5 cm which are inclined to each other at an angle of 60 degree. Now let us first draw a rough sketch. We are going to have a circle like this, and we are going to draw two tangents to the circle from a point such that the inclination or the angle between two tangents is 60 degree. Now in the rough sketch itself, if you join the center of the circle, say O, with the point of contacts of the two tangents, say L and M, so we get two radii OL and OM. Now children, if you name the outside point or the exterior point as point P, PMOL is a quadrilateral. And what is the sum of all the angles of the quadrilateral? It is equal to 360 degree. So angle P plus angle PMO plus angle OLP plus angle LOM is equal to 360 degree. As it is given, the value of angle P is 60 degree. PMO and OLP should be 90 degree because radii are perpendicular to tangents at the point of contact. So the only unknown angle is angle LOM. So we find out that angle LOM is equal to 360 degree minus 60 degree minus 180 degree, that is, it is equal to 120 degree. This means that the angle between OL and OM should be equal to 120 degree. So children, let us start with the construction. So let us draw a circle of radius 5 cm and name the center as point O as we did in the rough sketch. At point O, draw an angle of 120 degree AOB. That is, first we draw a radius AO, then we construct an angle of 120 degree in such a way that angle AOB is equal to 120 degree. Now draw an angle of 90 degree at point A. To get ray AX such that angle XAO is equal to 90 degree. Then at point B, draw another angle of 90 degree and get ray BY such that angle YBO is equal to 90 degree. The point where two rays meet, we mark the point as point P. Children, PA and PB, they are tangents to the circle and they are inclined to each other at an angle of 60 degree. Let us do another question. Draw a line segment AB of length 8 cm. Taking A as center, draw a circle of radius 4 cm. And taking B as center, draw another circle of radius 3 cm. Construct tangents to each circle from the center of the other circle. So children, let us start with this construction. First of all, draw a line segment AB is equal to 8 cm. Taking A as center and radius equal to 4 cm, draw a circle like this. Now keeping tip of the compass at point B and radius equal to 3 cm, draw another circle. Children, now we have to construct tangents to both the circles from the centers of the other circle. First of all, let us look at the circle with center A. We have to construct two tangents to this circle from point B. So how do we draw tangents to a circle from an exterior point? First of all, we join the center of this circle with the exterior point. But in this case, it is already joined. Now we will draw a perpendicular bisector of this line segment AB. So let us do this, keeping the tip of the compass at point A and taking radius equal to more than half of AB and slightly less than AB, draw two arcs, one above AB and another below AB. Now with the same radius and keeping the tip of the compass at point B, draw two arcs, cutting previous arcs at two different points. Let us name these points as M and N. Join MN. The point where it intersects AB, let us name this as O. Now with O as center and radius equal to AO, draw a circle which is cutting this circle with center A at 2 points. Let us name these points as point P and Q. Join BP and BQ. So these are tangents to the circle with center A from the external point B. Now children, similarly, we have to draw tangents to the circle with center B from the point A. So the method remains same. First of all, we had to join the external point with center, which is already done. Then we had to draw perpendicular bisector of AB, which is again already done, that is MN is the perpendicular bisector. Then we had to draw a circle with center O and radius equal to OB, which is again already done in this question. Now the point where this circle is cutting the circle with center B, we name those points as point L and F. Join AL and AF. So we have got two tangents to the right hand side circle so easily. So children, isn't this a very interesting pattern or construction that you have got? So children, look at this question. Draw a circle with the help of a bangle. Here we have not used a compass, but we are going to draw a circle with the help of a bangle. Take a point outside the circle. Construct the pair of tangents from this point to the circle. So children, take a bangle or any other circular object and draw the circle. Take any point outside the circle. We have to draw tangents from this point to the circle. But children, we already done that we can draw tangents if we join the center of the circle with this external point. Here we do not know the center of the circle. So how do we start with it? First of all, we will locate the center of the circle. We have done this in our previous class, that is class 9. For this, we will draw two chords of this circle. Let the two chords be AB and CD. Now we will draw perpendicular bisectors of these two chords. Let us first start with AB. Draw perpendicular bisector of chord AB like this. Now draw the perpendicular bisector of CD like this. The point where the two perpendicular bisectors intersect each other, name it as point O. So here we have got the center of the circle. Now children, we have the external point, that is point P. Join O with P. Now we have to draw two tangents to this circle from the point P. For this, we have to draw perpendicular bisector of OP. Children, we have already practiced how to draw perpendicular bisector of a line segment. The point where this perpendicular bisector intersects OP, name it as point, say M. With MS center and radius equal to MO, draw a circle which is cutting the previous circle at 2 points. Say K and L. Join PK and PL. So here we have got two tangents to this circle from the external point P. Let us do another question. ABC is a right angled triangle in which AB is equal to 6 cm, BC is equal to 8 cm and angle B is equal to 90 degree. BD is perpendicular from B on AC. The circle through BCD is drawn. Construct the tangents from A to the circle. So children, let us start. First of all, we have to draw the triangle. Let us draw BC is equal to 8 cm. At point B, draw an angle of 90 degree. Like this. Now cut this 90 degree angle ray to a length of 6 cm from point B. Name this point as A. Join A and C. So we have got triangle ABC. Now we have to draw a perpendicular from B on AC. How do we do this, children? You have done this in previous classes. Keeping the tip of the compass at point B and taking a convenient radius so that this radius will enable us to cut AC at 2 points, say E and F. Now with the same radius and keeping the tip of the compass at point E and F, one by one, draw two arcs above AC. Let the two arcs intersect each other at a point, say G. Join B and G. This is the perpendicular from B and which is cutting AC at point, say D. So BD is perpendicular from B on AC. We have to draw a circle which should pass through points B, C and D. Children, if we draw a circle with BC as diameter, it will certainly pass through point D because angle BDC is equal to 90 degree and we know that angle in a semicircle is 90 degree. So to draw a circle with BC as diameter, we first need to take midpoint of BC. For this, draw bisector of BC like this. Now with OS center and radius equal to OB, draw a circle. Now we have to construct tangents from A to this circle. Children, you know that to construct tangents, we need to join external point A with center, that is O. Now draw the perpendicular bisector of AO. Let this perpendicular bisector intersect AO at point M. With MS center, draw a circle cutting the previous circle at 2 points, say P and Q. Join AP and AQ. These are tangents to the circle. So children, in this chapter we have studied how to divide a line segment in a given ratio, how to construct a triangle similar to a given triangle according to the given scale factor, which could be less than 1 or greater than 1. We have also studied how to draw tangents to a circle from an external point. I hope you have understood this chapter and enjoyed it. Practice a lot more questions like these and keep practicing, keep progressing. Thank you and have a nice day.